The clearest image of Proxima b ever captured has just been released by the James Webb Space Telescope, stunning astronomers and captivating the global scientific community. Proxima b, located just over 4 light-years away in the Alpha Centauri star system, has long intrigued researchers due to its position within the habitable zone of its red dwarf host star, Proxima Centauri. For years, this small rocky world existed in the minds of scientists as a distant possibility detected only through faint signals, tiny wobbles in starlight, and subtle dimming events. Now, for the first time in human history, we have a direct, incredibly detailed image of this alien planet. Captured through layers of thermal and infrared imaging, the image offers more than just a glimpse. It marks the beginning of a new era in exoplanetary exploration. What makes this image so monumental isn't just its unprecedented clarity. It represents the culmination of decades of advances in optics, engineering, and astronomical instrumentation. The James Webb Space Telescope, now operating from its orbital perch beyond the Moon's gravitational influence, has finally directed its attention toward Proxima b with a precision and intensity unmatched by any previous observatory. Unlike the Hubble Space Telescope, which specializes in visible and ultraviolet light, Webb operates primarily in the infrared spectrum. This allows it to peer through interstellar dust and cut through the noisy radiation of red dwarf stars to isolate and identify the planet's thermal signature. What Webb has revealed is far more than a distant silhouette. For the first time, we can see surface gradients, hints of a landscape marked by topography and varied terrain. The image shows signs of atmospheric composition and potential climate patterns. Light and shadow trace across the planet's features, creating a visual language that, despite its alien origin, feels eerily familiar. This once hypothetical world, discovered in 2016 using radial velocity methods, was always compelling because of its mass, approximately 1.2 times that of Earth, and its potential rocky composition. But what truly set it apart was its orbit, just 0.05 astronomical units from its star, a mere tenth the distance between Mercury and our Sun. And yet, thanks to the much lower luminosity of Proxima Centauri, the planet falls comfortably within the habitable zone. Despite its tantalizing placement, Proxima b has remained cloaked in uncertainty, especially concerning its ability to support an atmosphere or life. Its proximity to a volatile, flaring star raised serious concerns. Could any atmosphere survive such relentless bombardment? Could life exist in such a precarious neighborhood? Those questions have now shifted into a sharper, more data-driven realm. With this new image, astronomers are beginning to infer characteristics about Proxima b's atmosphere that were previously only speculative. By analyzing the planet's infrared light patterns, scientists are identifying chemical markers that hint at a stable, though likely thin, atmosphere. There are also signs of thermal variability across the surface, which may indicate the presence of liquid water or active atmospheric processes that help redistribute heat. In certain areas, the radiation patterns suggest cloud cover or perhaps dynamic weather systems. This isn't a planet frozen in stasis under the harsh gaze of a red dwarf. It appears to be a living, changing environment. One of the most debated issues in exoplanetary science has been the habitability of tidally locked planets, those where one side eternally faces the star while the other remains in darkness. Could such a world support life? The new image sheds important light on this question. Along the Terminator line, the twilight zone between night and day, Webb's data reveals a surprisingly smooth heat gradient. This implies the presence of atmospheric circulation, capable of moving warmth from the star-facing side to the cooler night side. Previous models often depicted such planets as divided into extremes, one hemisphere scorched by unrelenting radiation, the other frozen in darkness. But the new evidence suggests Proxima b may have a narrow, temperate zone. A band of perpetual dusk where conditions are more Earth-like than previously believed. Additionally, spectral analysis indicates that the planet's surface is composed of silicate rock much like Earth's crust. Even more intriguing are unconfirmed signs of hydrated minerals, which could suggest a history of water. While oceans in the traditional sense remain beyond the detection capabilities of Webb, there's a subtle spectral signature that might indicate the presence of water vapor, given how tightly the presence of water is tied to the potential for life. Even this hint is groundbreaking. The discovery of a potentially thin atmosphere is particularly critical. Proxima Centauri is known for its intense solar flares, which can blast planets with high-energy radiation. But if Proxima b still has an atmosphere, it either means those flares are less destructive than we feared, or the planet possesses some kind of defense, perhaps a magnetic field or chemical shielding mechanism that helps it retain its gaseous envelope. This revelation rewrites assumptions about planetary survival in hostile star systems. It also reinvigorates broader questions about how many other impossible planets may actually be viable. The broader implications are vast. That Webb can capture an image with this degree of clarity of a planet just 4 light-years away transforms direct imaging from a distant dream into an approaching norm. And this wasn't a blurry infrared impression of a gas giant. It was a focused capture of a rocky exoplanet, delivering data so detailed that scientists can analyze topography, heat distribution, and even cloud patterns. It brings us closer to studying dozens, maybe even hundreds of nearby Earth-sized planets in similar zones of habitability. For years, Proxima b existed in the public imagination as a symbol of what an Earth-like exoplanet might be. Now that symbol has been replaced with real data and actual image. That image is more than a technological milestone. It's a philosophical and existential one. It transforms science fiction into science fact. What was once an artist's conception can now be grounded in observational truth. And that leap from imagined to observable redefines how we see our place in the universe. Astronomers are already revising models of Proxima b in light of this image. Climate simulations, once based on theory, can now be cross-referenced with direct thermal data. Geological assumptions about its crust and internal structure are being refined with new spectral information. Even models of Proxima Centauri's behavior are being adjusted, as we now have visual feedback of how its radiation actually affects a neighboring world. The release of this image has reignited public enthusiasm for interstellar exploration. Though human missions to Proxima b remain far beyond current technological capabilities, the idea feels less distant now. Projects like Breakthrough Starshot, which envision sending miniature probes to the Alpha Centauri system within a human lifetime, gain renewed momentum. Proxima b is no longer just a theoretical waypoint, it is a real, observable destination. This breakthrough also serves as a powerful validation of the James Webb Space Telescope's capabilities. When it launched, it carried immense expectations from probing the early universe to studying exoplanet atmospheres. Now, with this capture, it has demonstrated even greater potential. Webb has succeeded in one of the most delicate feats in astronomy, imaging a small, rocky planet close to a bright star. It's akin to spotting a firefly next to a lighthouse from miles away and not just seeing the firefly, but studying its wings, its body heat, and its movement. It's an astonishing technical triumph beyond science. The emotional and philosophical impact of this image cannot be overstated. For the first time, humanity has laid eyes on a distant, potentially habitable planet not as an abstraction, but as something real. It reshapes how we think about the night sky. The stars we see are no longer just points of light. They are solar systems, many with planets, and some of those planets may be not just livable but visible. The emotional response has been powerful. Veteran scientists, people accustomed to numbers, data, and charts have described moments of awe and wonder. Some have compared this to seeing the first images of Earth from space, just as the blue marble image from Apollo 17 reframed our understanding of Earth as a fragile sphere in the vast void. This image of Proxima b echoes that feeling in reverse. It is the mirror image of Earth, suspended far away, yet stirring. A familiar sense of home. It calls to something deep and primal in the human spirit, the drive to explore, to know, to connect. We now know that Proxima b is real, solid, visible, a world we can study. And maybe, one day, visit. Let us know what you think about this extraordinary achievement. We'd love to hear your thoughts on the new Proxima b image. Thank you for joining us, and we'll see you next time.